I'm really happy to be here. I've met some amazing people at this conference, and I just followed like a bunch of amazing speakers, so we'll see how close I can get to that at this talk. But yeah, so we're just going to jump right in. A quick about me, as Taylor said, I was just at Squarespace, left there a couple weeks ago. I'm starting a new role next month, but right now this is a fun time to be at this conference because I don't have a job. The vendors have nothing to sell me because I don't know what our stack is. And I say that with love, being previously a vendor. A little bit about me. I'm in New York City. Grew up in Florida. I like outdoorsy stuff. There are no mountains in Florida, so I'm happy to be in a state that has mountains now. And I'm really passionate about volleyball. It's the only sport I'm not terrible at. You can find me anywhere on the internet at RIKTURR. That's Twitter, LinkedIn, any social medias, any websites. Also Gmail if you want to email me and ask me any questions. So I was most recently at Squarespace. I worked a lot on the analytics platform, so that encompassed tools like BigQuery, dbt, Looker, and Airflow primarily, also some Trino. And my role was as a lead on the software side, basically making sure that the teams of analysts and analytics engineers that we had there could do their job in the most efficient ways possible. And I was kind of building stuff behind the scenes. And you're going to see a couple examples of some things that I built and learned along the way. And that's kind of how this talk came up, because we used dbt. I had to learn about dbt, and I had to build stuff on top of it and had to go really deep. So I'm hoping to share that with all of you. Quick intro into dbt, because actually surprisingly there's not a huge dbt presence at the conference here. Maybe it's kind of, I know there's the keynote later, there's a couple folks from dbt here. For a lot of people it's an assumption that everybody knows dbt. For some people may have never used it, so I'm curious just because I can actually ask you now, because we're at an in-person talk. Can you raise your hand if you've heard of dbt? Use it at your job? Cool. Have you ever extended dbt or built something weird on top of it? Okay, cool. So this is going to be going towards that latter end of the route, so hopefully we can increase those numbers of hands for the next round. But for those of you who don't know, the way I like to think about dbt is that it brings software engineering fundamentals to SQL-based data pipelines. And there's an asterisk because now, it does Python also, but we're just going to keep it at SQL for now. And so some of the things that come out of the box that makes this really helpful when you're thinking about this as a software engineering project is that there's like a project structure that's enforced, and there are ideas about it, and you may not agree, but at least everybody is using the same thing. SQL has a challenge that it's really hard to reuse components, right? It can be very verbose. So there's Jinja templating for you to be able to reuse portions of the SQL so that we can make the code easier to read. A really nice big part of dbt is the environment separation. So you can kind of do development in one place in your warehouse in kind of a scratch area and then deploy the same exact code into production. As well as this project structure enforces good testing and documentation practices. And really, dbt birthed this idea and field of analytics engineering. So when we're talking about dbt today, I'm going to focus on the open source part, dbt core, because that's what we used at Squarespace. And here's a quick just like, if you haven't seen dbt, on the left side there's a SQL file, and that's kind of the basis of everything that happens in dbt. A single SQL file is called a model, and it comprises a select statement, which creates a table in your warehouse. So dbt, that's kind of like the building block, right? And so you can see here we have some CTEs, we have some things, but then we have some weird curly braces, right? And so that's where the templating starts to come in. At the bottom, we can see a for loop that'll kind of like write a bunch of columns for us. And then you can see these kind of like ref statements that'll help tie different models together. So you can say one model depends on another one. That one has to be run and created first, and then this other one can reference it. On the right-hand side, you see a YAML file, which corresponds to this model. And this is where all the testing and documentation comes in. You have the name of the table, the description, all the columns enumerated out, and certain tests like the primary key has to be unique, and different things. And so this is mostly what you're doing and writing when you're writing dbt. As far as running dbt, dbt comes with a command line interface, and it's a package that you install, but then you run this command line interface, and as long as you're in the directory of your project, you can run a bunch of commands to do different things with your project. dbt build will basically execute your entire project. So that'll run all the models, it'll test them, it'll do documentation for you, it produces like a doc site and all of those things. But actually what's happening behind the scenes, you see all this running and everything, right? What dbt is doing is it's sending that SQL statement to your data warehouse, whether that's Postgres, Snowflake, BigQuery, any database system that dbt supports or their community adapters for it. And then it's not running that original SQL statement that I showed you, right? Because that wasn't actually real SQL. Those curly braces would fail if you try to run it in BigQuery. It compiles a real SQL file, which it then runs against the warehouse. So this is an example of that compiled one. Now you can see it creating a table. You can see the real table name from that reference that I showed you earlier. And that's, generally the idea of what dbt does. This is actually this compiled SQL file is not part of the code that's in your project. It actually gets generated. And that brings us to dbt-artifacts. So, we talked about dbt, what it is. Artifacts are things that the dbt code produces. You don't write this code. You don't check this into your version control. But it's something that happens kind of on the fly. And I think I should have put this slide before we got to the artifacts thing when we were talking about the project. So I showed you a SQL file, showed you a YAML file. Here's what the structure of a typical dbt project looks like. We're using the classical Jaffle Shop project, and which is kind of just like the hello world for dbt, if you can call anything classical. I mean, dbt is not even that old yet. But you can see here that there's a dbt project.yaml file, which is I'm showing you the contents there. That's the configuration of your project. There's a bunch of settings that we don't need to go into here. And then you have a models folder, which has all those SQL files and those YAML files and documentation and such. And so this is all the code that you're writing. You're checking into your branch that's for your project. The artifacts, like I mentioned, are the components that get produced when you execute anything on your dbt project. So they're basically files that describe your project, but you didn't write them. So typically this goes in the target folder, and you're not writing these files. These are just the exhaust of dbt needs to do some stuff to figure out what it's going to run, and this is the exhaust of what that happens. And you can check out the docs to see like what all the different artifacts are. There's a bunch of different ones, but we're going to focus today on the one, I don't know if you can see it, like the 7th one down or something, called manifest.json, and that's the manifest. That's what we're going to talk about today. So what is it? I'm going to let you read this because this is copied and pasted from the dbt doc site, and I don't like reading slides, so I'll give you a moment for that. On the right side is basically like a minimized preview of what this manifest JSON file looks like, and I'll talk about that more when everybody's done reading. Cool. Okay, so like my definition of it, the quick kind of easy way is that the manifest file is a machine readable file that has everything that you need to know about your dbt project, or it describes your dbt project, everything about your dbt project in one place. And we can see here that there's some metadata, there's nodes, sources. Like I'm not going to explain all the individual pieces of this, but if you're already using dbt, open up this JSON file, and there's a tip. It comes just formatted as like one line. And get some like JSON formatter. If you're in Sublime, you can install a plugin called PrettyJSON, or if you're in VS Code, there's like hotkeys to auto-format your JSON, and then you're going to be able to kind of read it better. But then, honestly, just reading through this single file gives you a lot of information about what's really going on behind the scenes in dbt and what things are configurable in there. A little bit more about this manifest file. Like I said, it's typically written to that target folder. You can control that setting. And it's updated on pretty much any time you run dbt space something. Because anytime you're running dbt, you're going to do something with your project, and it's going to update this manifest file. And if you're going to use this, that's kind of the goal of this presentation, which we'll get into, you have to understand that if you change any code in your dbt project, the manifest file doesn't automatically get updated, right? You have to run some kind of dbt command, and then it will update it. And it's always going to the manifest file is always going to have your whole project. Even if you say like dbt run, just like model 123, it's still going to have everything because it needs to know the full kind of like global spec of your project, even if it's just going to execute one component of it. Okay, so this is that same SQL, I think, on the left, right? And then on the right side, I'm showing you an example of what the manifest file looks like for this specific model. In this case, they're called nodes. Like there's models, seeds, are all kind of nodes. But I'm going to highlight just kind of one aspect. Again, you can dig into the manifest yourself to see the individual pieces. But for instance, I'm using this ref statement, right, to say that this customer's model depends on another upstream model called stage_orders. And we can see that we're inside of our customer's model in that JSON file, and we can see that there's a depends on key a few lines down, and then inside of that, there's another section called nodes, and you can see a list of 3 items. So those are all of the nodes that are upstream of this current model. So if that information is important to you or your system, you can start to use that in kind of like in somewhere. So hopefully I'm starting to get some gears turning on like how you can like extract information about your dbt project from the manifest file. And this whole talk is all about using the manifest file, right? And what do I mean by that? It's basically, like I said, it's a machine readable file. So you're going to write some kind of code to process this file and do something either automatically on a schedule or so on. If you're a person that needs to see your project, you can just go to the regular folder and look at all the contents of your dbt project, right? You don't have to look at the JSON file. But in this case, it can be a Python script, something in a CI tool, so on. And so the goal of this presentation here was to kind of just give you a background into the manifest file, tell you what it is so that you know what's running under the hood, but also mostly to inspire you to use the manifest file in any sort of applications at your organization. The rest of the talk will be kind of giving examples of that, but hopefully the best conference talks I think is you'll get one little nugget of an idea of something, and then you go back next week, go back to work, and then start kind of tinkering on that. Hopefully you can get at least some kinds of ideas from this talk. So as far as using the manifest file, I have just a Python script here, really simple just to illustrate it. We're running the kind of bash commands from dbt. And like I mentioned, you always want to make sure that you're updating your manifest file if you're going to read it. So in this case, we're running dbt-deps, dbt-compile to make sure the manifest gets updated, and then using a JSON load statement, right, to load that JSON file. And then on the right, I have a REPL open here, just kind of calling this function, pulling out the manifest that comes back as a dictionary, right? So I go into the nodes, I go into the particular key that I was showing you on the other screen, and so now I can get that back inside of my Python function now. Cool. Okay, like I said, the rest of this talk now is going to talk about different applications and use cases of ways that you can use the manifest file. So there's a few categories here. Some of them are going to be heavier than others, but we'll start off with Airflow orchestration, because I think this is one of the heavier sides, but one of the really powerful use cases of being able to read machine-readable versions of your dbt project. This is going to be a mix of stuff that I've built at Squarespace and stuff out in the community. I'd say probably about half and half. So I'll make sure to indicate when it's something that I built versus something that's kind of already out there. This is something that inspired something that I built, which we'll talk about in a second. But there's an article out there from Astronomer and some other folks about kind of creating Airflow DAGs based on dbt projects. And so basically what this does is it makes if you're not familiar with Airflow, right, Airflow is an orchestration tool. It also uses the concept of DAGs and graphs, where you can have a task that runs and then another task after it, and then the second task might depend on the first task, and then you schedule those to kind of run together. If you think about the way that your dbt project runs with multiple different models that also depend on each other, it's the same kind of paradigm. They call them both DAGs. And so the idea here is that if you wanted to schedule your dbt project execution in Airflow, you could just have a bash operator task and say dbt build, and then it runs in that task, right? But let's say you have 100 different models. Some take a second to run, some take an hour to run. If any one of those single models fails, your entire Airflow task will fail, right? And you wouldn't know which one failed until the end of the execution. And if you wanted to rerun just one single model that failed, you would end up rerunning all of them because it would just be your whole project at once. So what this shows is a way to run one task per dbt model, basically making your Airflow DAG match your dbt DAG. And the contents of the manifest that it uses here is that same nodes depends on key that I showed you earlier. So here's a little preview of what this looks like. On the left is code that I just literally copied from the blog article. You don't have to kind of read through all of that, but you can see things where those keys that we were talking about before, the nodes depends on, you can see those going through for loops and such. And kind of circling the same contents I showed you there. And then on the right side is an example of what this Airflow DAG looks like. If you were to open up your dbt docs site, your Airflow DAG would look very similar. Now we get dependencies between all of these things. Okay, so building on top of that, this inspired something that we ended up building at Squarespace. Very similar kind of idea, right? A lot of the code was taken straight from that article with some kind of specifics to the context of our organization, and that's kind of always how things happen, right? If you have to build something at your place, there's always different nuance and context there. And so, the implementation of this was, again, very similar, but the reason why we needed this was, for the same reasons that I just discussed earlier about instead of having one task, you're gonna have multiple tasks, you have better observability into your task failure, rerunning. But a little bit deeper into why we needed to do this is that Airflow is the orchestration tool at Squarespace. I didn't have a choice in that, right? And it's kind of already there, it's already built. We're building dbt stuff. But the users who are using dbt shouldn't really have to know Airflow and have to deal with Airflow, right? We have a lot of analysts and analytics engineers, data scientists writing dbt models. It all works nice, right? They can run on their machines, they can test things, but we don't want to have them to go into have them go into the Airflow, change all the Airflow Python code just to update things. So basically that was kind of my job, is to build this infrastructure so that way they don't have to do that. But also what we did is we extended the dbt operations. So not only just running a model, you could now automatically have a test task immediately after your run task all the time. We were creating external tables sometimes in certain use cases. So these are all things that were kind of like custom to what our workflows needed. And we would just add those automatically into the DAG without people having to kind of write those tasks themselves. There were some things like custom alerting for individual models. We then added tags inside of the model files or inside of the YAML where you can say, alert this Slack channel if this model fails or if this group of model fails, but it could all run in the same DAG, so you wouldn't have to set up like multiple DAGs to make the Airflow more complex. So this is kind of what it looks like. That's the name of the class, was this DAG builder. And of course, I'm obfuscating some of the task names, not that it's like terribly sensitive. But there's an example here of just on the top right, 2 models that run. Right, there's no really dependencies between them, but we have a Sentinel start task, and then we have all of our dbt tasks in the middle. There's a run task there, and the external table task comes immediately after, and then we have a Sentinel end task. So these start and end tasks are actually really important and really helpful, because if that DAG is doing anything besides dbt, you can then have something upstream that runs, like if you want a test task before the start, or if you want to like have a docs task after the end, or even non-dbt operations, you can kind of now mix your dbt execution into some other DAG that's doing other things. And on the bottom here is just an example of like, one big DAG where there's not really any dependencies between the models. We have other ones now with hundreds of tasks and dependencies, but I wasn't able to grab that screenshot. Okay, one other aspect on this is the deepest that I'm going to go into any of these use cases. Beyond just like, what do we do with the manifest file and how do we read it and how do we parse the DAG, is like, how do you actually keep this DAG up to date, right? Because what Airflow does is it runs your kind of DAG file, your Python file constantly, all the time, to make sure and pick up any changes in the DAG structure. And so, there was a couple options for this, right? It's like, we were using CI/CD, practices and feature branches and then merges to the main branch. What we ended up going was with this first option, actually, was dynamically like updating the Airflow DAG during the DAG parsing. So what that meant is that anytime somebody changed the dbt project code, we had to push that to Airflow. And we already had mechanisms internally for the Airflow. It was on Kubernetes, the Airflow pods, getting the files up to date. So the files were kind of already up to date. But dbt, again, the manifest file, because we're reading the manifest file to understand the structure of the Airflow DAG, we needed to make sure to update that manifest file. And to update that manifest file, you have to execute dbt. And to execute dbt, you have to connect to your warehouse. So this actually takes a few seconds, sometimes like 20 seconds to a minute to compile your project. So we had a lot of Airflow settings that we had to tweak to kind of get that right, because Airflow DAG parsing usually assumes that it takes just like a couple seconds. And then one other aspect we had here, as far as like environment separations, we made sure to execute dbt in an isolated virtual environment, so that way the Python environment for Airflow wasn't conflicting with the dbt environment. And the reason that we did this, so actually the second option is way easier. So let me go into that first and say why we did the first one. The second option is a lot easier because if you just upload your artifacts at build time, so when a main branch merges, you can upload a JSON file just like S3, right, or GCS, and then pull it down when you need it in Airflow. That's actually really easy to do, right, because this is an artifact of dbt. You can move that single JSON file around and it has the exact description of your project. The problem why we didn't go with this option is sometimes in our DAG structure, we wanted to only execute a subset of our dbt project. We're using select or exclude. So we say we're going to run these certain models twice a day, and all the rest of the models run once a day. Those need to be in different DAGs, and that DAG builder class now needs to just select those. So if we needed to cut up our dbt project, it was a lot harder to do that from the JSON file itself, because those dbt select and exclude statements are very complex. Right, there's like set operations, group operations, you can select tags, you can exclude things, you can ask things that are downstream of a node or upstream of a node. So we would have had to rebuild all of that selection if we were going to do this second option. So we ended up, both were going to be a lot of work, we ended up doing the work to actually just execute dbt inside of the Airflow environment. Okay, so that was like the deepest I'm gonna go into anything. That went like beyond dbt, that went into Airflow a little bit. So hopefully I can kind of bring you back and talk about a little bit more use cases, but that was just something that was really fun to build, so I just couldn't help myself like talking about that. All right, next category we have here is developer experience. So we'll go into one more Squarespace example, and then I promise there's more community ones here. And so this is, so when we're talking about developer experience, right, we're talking about like how can people build most efficiently and make sure that their code is correct as quickly as possible, right? Prevent failures as soon as possible. And so one way you do this is through, continuous integration, continuous deployment practices, right? dbt has ways for you to kind of do, what are they called? Just like do CI, like Slim CI, executing your project and things like that. So, the typical way that you would think about it is somebody writes some code on their machine, they test it, it works. Before you merge it into your main branch, you want to make sure that you execute this somewhere in a production environment. The problem that comes in when we're talking about data is that sometimes that execution on the production environment will take an hour to run, right? And you don't want to wait an hour for every single model to run every time you want to change like one single character in your code. So one thing that we ended up doing that turned out like really well to kind of like help with this is executing dry runs. So we were using BigQuery and Trino, and both of these support dry runs, and I think other warehouses would support it as well. And so in BigQuery, it's actually called a dry run. And so what this is it'll take a query, and it'll basically do the work to build the query plan, but it won't execute the query. And so first of all, it's really fast. And then second of all, it's going to know if a table doesn't exist, if a column name is wrong, or if your SQL syntax is wrong. So that's typically most of the time what goes wrong to break a SQL statement, right? Otherwise it'll run, it might still be wrong, the output, but at least we can catch if there's something wrong. Like, it's just like when you're dealing with like a lot of people who might be new to a system, it's like, you're supposed to run code anytime you change it, but that doesn't always happen, right? Sometimes people are in a rush. So we want to make sure that we're always executing it. And so that's what we did. So from the manifest file, we took that, we could get the compiled SQL, basically, the real SQL that dbt would run. We pass all that through to BigQuery and just do a dry run on all of it. Like multi-threaded, so it happens really fast. So now every time somebody changes code, every single model now gets a dry run. You catch it anytime there's like a syntax error. One kind of nuance to this is that let's say you're introducing two new models in your new change, model A and model B. Model B depends on model A. If you're using the compiled code, the model B SQL is going to try to select from model A. But model A, because this is development, doesn't yet exist in your production database. So when it tries to run that, it would fail. So the way that we worked around this is that I would actually copy the whole dbt project into a temporary place, and then add a config line to the end of every single SQL model, force them all to be ephemeral, which if you're not familiar with dbt, there's different materialization strategies, which means like, this model is going to create a table in the warehouse, or this model is going to create a view. Ephemeral means don't actually create a table, but just take this SQL and inject it as a CTE in your downstream model. So what this does now, every single SQL file for every model is now self-contained, and it'll be able to run all the upstream models as CTEs inside of them. Again, it's not running them in the dry runs, it's just doing syntax checking and things like that. So it actually makes that really nice. The only problem that we run into is that BigQuery has a limit to the complexity of your queries. So if you have a big chain of a lot of different models, it just like flat out won't run the query. So there's like nothing you can do. I'm hoping somebody there solves that because I'm not there anymore. And here's just like some code again. I wanted to be able to show it. We're loading our manifest file with that function that I showed you earlier up here, and then inside of that, grabbing the compiled SQL path from the target folder, and then there's just like the nuance of like how dbt chooses to kind of save those files. You read that as a text file, and then you pass it to the BigQuery client, and the major key is to make sure you pass this dry run parameter as true. Otherwise, it's going to try to actually execute the query, which could take a long time. An additional thing that we did was to make a separate service account that was not the production service account, that didn't have write access to the destinations, so that way you don't accidentally write to your database when you don't want to. And then on the right there, we can show the dry run succeeding. Probably should have showed it failing so you could actually see that, because like that's the main benefit to it. But if it fails, the BigQuery API or client has like a really nice kind of like failure messages, which will tell you what's wrong. You change it, push it back up, then it should be good. Okay, so it's examples of things that I didn't build. I went to Coalesce 2021 virtually. Yeah, that one was virtual. I didn't go to 2022, so these examples are like a year-ish old, and it was at like the end of 2021, so it's not that old. I know like things move fast in this world, but hopefully this stuff still is applicable. So there was this talk that I watched from Darren at AutoTrader, and they were doing basically they were using dbt metadata to enforce kind of best practices and rules at their organization. And so this is really cool, right? So you can see here, there's this meta key on that YAML on the right. You can add whatever you want to this. In this case, they were showing who the owner was, and there's this other tag called model maturity, which I thought was really cool. So you could still kind of like develop and test and iterate on models, but you can say, hey, this isn't prod, don't use this in your dashboards, don't show this to the CEO yet, but you can still kind of have it in the warehouse for people to play around with. And they basically enforced contracts between teams by using this metadata. It was all documented in one place, and then they had CI/CD checks to make sure that every single model had these meta tags, so that way everything would always be documented. You couldn't make any changes or add any new models unless this was there. So again, this is ways to enforce quality, to make sure people know, help documentation, so that's all helps kind of this world of developer experience. I'm going to take a quick sip of water while you ponder that. Okay, we got two more. The next one I'm going to talk about is external configuration, and this is, I don't have as many examples on this because I'm not that creative, I guess. But this is something, one of those things where it's like I want to just seed this idea in your head that you can use dbt to configure things that aren't dbt. So here's one, I think it's just one example that I have, yeah. One example also from Coalesce, this was Tegan from community.com, showed how they use the manifest to do this exact thing, configuring external systems. So the example that I have here on the screen was for Slack alerting, right? So they actually use those same meta tags that I showed you in the previous slide, and you would put like the Slack channel of who needs to be alerted when this model fails, and then whatever system you have to execute, whether it's Airflow or not, can know, okay, we have to now send this Slack alert. And so they were building a system that reads that, and then now there's some microservice that's sitting there. It's consuming the manifest file anytime that gets updated, and then it's deciding, oh, do I need to send a Slack alert right now? Yes or no, and it's doing all that work there. And so like the big kind of like mind-blowing part to this for me is that you can build a microservice that reads your dbt project and does whatever you want, right? And so again, in keeping people in their best tools, you can now have people who wouldn't be the kinds of person who's writing a microservice to send Slack alerts or to update data or send things into another system, but now can control and configure those systems, right? And so that's like the main idea. And like I said, I wasn't kind of creative enough to come up with other ones because I never had to do this at my job, but hopefully you can kind of think about this and maybe come to the office hours and we can brainstorm some other ideas later. Okay, the last section here is observability, and this is going to go a little bit beyond the manifest, but it ties into the artifacts in general, so I think it's kind of in the same vein. Okay, so the first part, I really like this package. It's called the dbt-artifacts package. It's actually a dbt package, so you would install it with dbt. And this is fun, and I was supposed to put the exhibit meme where he's like, I like use dbt on your dbt. I don't know, that's kind of dating me a little bit and my humor. But what this does is it takes all those dbt artifacts that I showed you as files, right? The JSON file, there's like a run results, there's like a message, like other stuff. And it actually creates models in your project that will write that data to your warehouse. So you're going to have, and the top right here is actually the dbt docs, DAG there, and you can go see an example. Brooklyn Data manages this, and they have it up on their GitHub, and they have the doc site live that you can see. And so what this does is it puts those in your warehouse, right? So like maybe you don't want to write a Python function like I did, and you don't need to write a Python function that reads generates Airflow DAGs, but you wanted to see how many models are in your project, right? You're managing this for a bunch of people, and you need to make sure, are people, doing things right? Which data sources are they reading from? All of those things. Again, anything that your dbt project has will be in these artifacts, and then these artifacts are now in your warehouse for you to query and to do your analytics engineering on top of, right? I showed you a screenshot here of one of the macros that actually pulls this data. So technically, it's not using the manifest.json file. But it's using the same contents from that. in later versions of dbt, what they have available are these, is this graph object, and I didn't circle it, but like on the third line, you can see for node in graph.nodes, that graph is a Jinja template, I think is what the technical term is, but like that's available in all of your macros and all of your Jinja. That's basically the manifest, essentially, but in a Jinja Python object. So in this case, they're pulling all of those things, and then they're creating models to kind of run and save the contents into tables in your warehouse. And then you can kind of read those and do whatever you want with them. It's pretty cool. And so like on this vein of observability, like dbt-artifacts allows you to kind of save all that contents into your warehouse, but that's kind of where it ends, right? That it's still in part of your dbt project. So there's this open source and a startup called Elementary Data that basically does the same thing as dbt-artifacts. It captures all of that data into your warehouse, but then it takes that and starts to do things with it, like kind of like for you, right? It'll do like visualizations of what your project looks like. It does monitoring and alerting, showing you when things change, showing you when things break, all of those things. And I haven't dug like super deep into kind of what this tool does. This is, again, just mostly an example of like what's possible with the manifest. And so you can kind of check out that project and check out that company too. But I think it's really cool, right? Because it's, again, it's like the power that you have as like somebody working in this field starts with the data, right? And so we're getting kind of meta about this, right? We're getting data about the things that we're doing to make our data. But it's just a data project like anything else, and you can get all kinds of information that you might need to know to make sure that your data pipelines are kind of like up to date, understand what's failing, understand what's wrong, understand technical debt, all those things. Okay, so those are all of the like deep dive examples. There's like too many applications for me to count and kind of like fit into this deck, and honestly, I didn't spend too much time preparing, more time to kind of like add examples for all of these, but I'm going to leave that as homework for you all. Another observability tool is called Redata. They do similar things, I think, as Elementary Data. Don't quote me on that. But they kind of read the dbt artifacts and do observability. There's a cool VS Code extension if anybody uses VS Code for your dbt code called dbt power user. It does like autocomplete and kind of like make sure your dbt syntax is correct and does a lot of other nice stuff for you locally that also reads the dbt artifacts and the manifest. And there's this project called dbt osmosis, and I didn't do a super deep dive into it because I haven't seen updates on it in the last few months. But it's a pretty cool tool and idea. I didn't run it, but it does like automated code refactoring of your project. So if you think about like your dbt project is going to have a lot of YAML files with a lot of docs, and you have to write every single column out and write descriptions for it. It helps you kind of like handle that well. And of course, it reads the artifacts because the artifacts describe your project. Cool. Okay, so I always like to do a quick recap because I threw a lot of information at you. Basically, the manifest is your friend. You should use it. You should look at it, build stuff on top of it. You can use Python. You could write it to your warehouse, and then you can just use SQL to analyze it. And some of the use cases I went through is like the Airflow orchestration, making your Airflow DAG match your dbt DAG, project testing or developer experience, right, to make sure that your code is going to run in your warehouse, make sure you're following organizational best practices. Other examples are kind of external configuration, right, like the Slack alerts that I mentioned, or ways that you can kind of tell other systems and build microservices on top of your project, as well as observability to understand the health of your dbt project, how things are running. And you can contact me, again, RIKTURR, anywhere. If you have any questions, I'll have the office hours after lunch. But besides that, I can probably have some time for questions now, and thank you.